Hello and welcome to MyScience Tutorials. In today's video we are going to be looking at coefficient of friction. So without wasting much time, let's get started. Now, what is coefficient of friction? Well, before we look at what coefficient of friction is, let's look at this diagram we have over here. So assuming we have a rough horizontal surface and then we have a solid object, okay, on this rough horizontal surface. Now there are certain number of forces that are acting on this body on this surface. First of all, should we want to move this body, okay, along this rough surface, then there will be a frictional force acting in the opposite direction which will prevent the motion of this body. So assuming we apply a force, let's say P, for it to move this object, then of course we have a frictional force acting in the opposite direction which will tend to oppose the motion of this body. Now, aside the applied force that we are going to apply and then the frictional force, we also have the normal force which is acting upwards and it is represented with R, and then we have the weight of the object acting downwards, which is equal to what? Mass times gravity. So these are some few forces that act on a body when the body is on equilibrium, okay, on a rough horizontal surface. Now mind you, friction can only be between a body and then a rough horizontal surface. Now if we have a smooth surface, there's no friction between the two bodies, because friction occurs, it tends to retard the motion of two bodies, okay. So when one is smooth, okay, that is our surface is very smooth over here, this body can easily move along the smooth surface, so there will be no friction. So friction can only occur when we have a rough horizontal surface or an inclined surface, any of them. Now in this scenario, okay, the forces that are playing part in this scenario are what I said earlier on. So we have the frictional force, the force that we are applying, the normal force, and then the weight. Now let's look at something. Now the frictional force over here, okay, is what? Proportional to the normal force holding the surface together. So the frictional force over here is what? Proportional to the normal reaction that is holding the body and then the surface together. Now if you are used to proportionality, you've been solving mathematics a lot, you get to know that whenever we remove a proportionality sign, we introduce a constant, and then the constant in this case is the coefficient of friction. So when we remove this proportionality sign, we have F is equal to what? Mu R, okay. Now this mu R, okay, is what we are referring to as the coefficient of friction. So it is a constant of proportionality, and then it is what? Dimensionless, okay, so which means it has no unit. All right, so this is in case we apply the force over here horizontally and not at any angle. Now let's have a look at the cases where the applied force is at a particular angle. Okay, so using the same diagram, assuming the applied force that we are going to apply now is at a particular angle to the plane, not horizontal anymore, but at a particular angle, okay. Now whenever that happens, okay, we tend to have the horizontal component of the force and then the vertical component of this force, okay. So in this example, because the force is now applied at an angle, our horizontal force that is acting on this body will be what? It will be what? It will be P cos alpha. That is the horizontal force acting opposite, that is preventing the frictional force from actually sliding this body backwards, and then the force acting downwards will be what? P sine alpha. All right, so in this example, if you want to look at all the vertical forces acting downwards, that is the vertical forces. Now the vertical forces will be equal to R. Now we have, this is one of the forces acting downwards, we can see the weight. Then this is the second one, which is the P sine alpha. So to get the total of the forces acting downwards, we will have W plus what? P sine alpha. And then someone can write, in place of the W we have what? Mass times gravity plus P sine alpha. Now in this case, the only horizontal force we have over here is the force coming in this direction, which is opposing the frictional force. So we have frictional force to be equal to what? P cos alpha. So let me make this equation 1 and this as equation 2. So these cases are really important when we are looking at bodies on a rough horizontal surface. Now mind you, whenever we have a smooth surface, okay, our frictional force, which is F over here, is always equal to 0. And then also note that the frictional force is proportional to what? The normal reaction. And then the proportionality sign, the constant of proportionality, is what we call the coefficient of friction, and it is what? Dimensionless. So if we understand the concept of this body, and then the application of force at a particular angle or horizontal to the plane, now let's have a look at some few examples to actually enhance our understanding about this concept of coefficient of friction. Okay, so let's have a look at example number 1. So we have, if a horizontal force of 200 Newton is just sufficient to start moving a body of mass 50 kg along a wooden floor, calculate the coefficient of friction, given that gravity is equal to what? 10 meters per second square. Now, so let's write solution. Now in this case we have what? A horizontal force of 200 Newton. So let's draw our, let me draw this quite straight as possible. Okay, so we know whenever we have a body on a rough horizontal surface, we know the forces that will be acting on it. We know, first of all, we have our normal reaction going upwards, we have our frictional force opposing it, then the force now we are applying, which is the P, and then the weight of the object acting downwards, which is what? Mass times gravity. Now the question is telling us, if a horizontal force of 200 newtons, which means we are applying a force of 200 newtons, okay, is just sufficient to start moving the body of what? 50 kg along a wooden floor, calculate the coefficient of friction. Now of course we know a wooden floor will be rough. No matter what, it will never be smooth. Even if you use sandpaper, it will never be that smooth. Okay, so there will be friction. So because it's not a smooth surface, friction is there. So we have our friction is equal to what? The coefficient of friction times the normal reaction. Now the question is telling us to find the coefficient of friction, so let's make it a subject. So coefficient of friction will be what? Frictional force divided by the normal reaction. Now this is giving us, now the frictional force in this case will be equal to the force that is being applied to move this body. So we have 200 newtons, okay, divided by, now the normal reaction R will be equal to the weight of the body, that is the force holding the body onto the surface of the wood. So in this case it will be what? The mass times the gravity. So from here we have 200 Newton divided by the mass of the body is 50 kilograms times the gravity is 10. So this is giving us 200 divided by what? 500. And then if we input this into our calculator, we are going to get 0.4. So the coefficient of friction in this example is 0.4. And like I said, it is dimensionless, so we don't have any unit because we have Newton here, and then here we have kilogram meters per second square. So this is also equivalent to newtons, so they will cancel out. So let's have a look at another example. Example number 2. Okay, so a body of mass 100 kg is placed on a rough horizontal floor. If the body is moved at a constant speed by application of a horizontal force of 500 Newton, calculate the force exerted by the floor on the body. Then II, the coefficient of friction. So let's solve this example. Now a body of mass, let's draw the diagram first. So we have a rough surface over here, then we have our body on it, our body of 100 kilogram. We have our normal reaction going upwards. We have our weight, which is equal to the mass times gravity acting downwards. Then we have our frictional force, which is opposing, and then we have our applied force P, which in this example is what, 500 newtons. Okay, now the first aspect of the question is telling us calculate the force exerted by the floor on the body. Now the force exerted by the floor on the body is just the normal reaction, okay, which is equal to the weight. So the normal reaction R is equal to the weight, which implies our R is equal to what, mg. So our R in this example is going to be 100, oh sorry, this is supposed to be 100, so it's equal to 100 multiplied by the gravity is given to us as 9.8. so our normal reaction, or the force that is holding that is exerted by the floor on the body, is going to be 980 newtons if we input this into the calculator. Now the II aspect of the question is telling us to find the coefficient of friction. Now we know frictional force is equal to what, coefficient of friction times the normal reaction. So our coefficient of friction is frictional force divided by the normal reaction, which is equal to what, the frictional force over here in this example is going to be 500 newtons. So we have 500 newtons divided by 980 newtons. Okay, so this will give us, if we punch this into the calculator, 500 newtons divided by 980 newtons, we are getting 0.51. so this is the coefficient of friction in this example. Yeah, that is how we solve questions about an object on a rough horizontal surface. Now mind you, if this example were to say a smooth horizontal surface, it means our frictional force over here would have been 0 newtons. So let's take note of that. So whenever you have a smooth surface, frictional force is always equal to 0. So with that being said, thank you so much for watching, and then I'll see you in the next video. Now remember, if you're new to this channel, consider subscribing as we post daily videos on physics, mathematics, chemistry and biology. So thank you so much for watching, and then I'll see you in the next video. Bye bye.